right, so let's start with Journal 5. So this spell work here is actually some problems you might see on your quiz that's going to be next Wednesday, September the 4th. So these problems here go back to the idea of those vocabulary that we learned back in that first week when we started our Algebra 2 class. And so we want to change this verbal expression, as you can see in here, to algebraic expressions, meaning like, can you write this, the words, translate the words into like equations and like into numbers and symbols? Like, how would you do that? And so let's read the sentence, the first sentence here. It says the expression has a coefficient of a -8 and two other factors. One factor is squared and the other is raised to the 5th power. Now, we learned that a coefficient, when I'm reading through this, you want to find those terms that kind of pop out at you, those math terms that we learned. So it says the coefficient, that to me tells me that there is a coefficient. A coefficient is a number in front of a variable like x. And so we have a coefficient of -8. So I know I have to write down a -8. And then next to it is going to probably be maybe some x and y's if I have them. So it says two other factors. So there are two other factors here. One factor is squared. So I'm going to double underline the squared part because that means I have an exponent. And the other is raised to the 5th power. So if I were to ask you what are, like, let's understand what the word factors means. So if I were to ask you what are the factors of 6, you would probably tell me 3 and 2, right? 3 times 2 gives me 6. When we think of factors, those are actually multiples, or things that multiply to give you the value or a number. And so in this case, there are two factors, but they didn't tell us what those numbers are, what those factors are. So we have to use variables. And so I'm going to use some letters here. X, maybe, since we always use X. And then I have to use another factor, a different factor. So I'm going to use Y. Now, they also said one of the factors is squared, so that just means to the 2nd power. And then the 5th power is the other factor, so I'm going to write this to the 5th power. Now, it didn't matter if I used X or Y or A, B, whatever letters you want, as long as they're different. And it didn't matter whether this X was the one that was squared or if it was raised to the 5th power. It just mattered that you had to have them on your variables. And I think that's it, because there's no more information afterwards. So let's try this one here. It's a bit longer. So when you're reading through this, like the first sentence here says the factor, or the expression, has 3 terms. So I already know that this here is going to have 3 terms. So I'm going to draw 3 lines here to remind myself that I should have 3 terms, or fill out these 3 lines when I get done, or 3 blank spaces. So in this here, it says the coefficient of the first term. So I know this is going to be the designated spot for this information. So it says that the first term here has a coefficient of a -5. So I have a -5. And it has one factor. So I probably have to put down a variable that is raised to the 4th power. So maybe this is going to be x to the 4th power. So I just have my coefficient, which they say was a -5, and it has a one factor that's raised to the 4th power, and so I have my variable to the 4th power. Okay, then the second term here, it says the second term has a coefficient of 6 and 2 other factors, one squared and the other cubed. So that's telling me, okay, I have a coefficient of 6, so I got to drop down to 6. 2 other factors, so this is a different factor than this x. So that means I have to use different variables. So maybe I'll start with y and then z, since there are 2 of them. One is squared, so maybe the y is squared, and the other is cubed, so the z maybe is cubed. And then, because they said that this is a coefficient of 6, it's a positive 6, right? So in this case, this is a positive 6, so in between these two terms, I'm going to write a plus sign because this is a positive value. Now, if this was a -6, then this would be a minus sign here. Okay? So that's how we can join terms together, is by figuring out what is it. Is it a positive value or is it a negative value? And then here in our last sentence, it says the third term has a coefficient of 9, but no other factors. So a coefficient of 9 means I have to drop down a 9, and it's a positive 9, so I need a plus sign here. But it says no other factors, so that means I don't need more variables. That means that this coefficient is not just a coefficient, it's a constant. And there we have it. We have our expression. And I guess I don't really need these lines anymore. So if you want to go ahead and erase that, you can. But you don't have to. You can keep those lines there. They were just there to help us out. But here is our expression. All right. So like I said, you're going to see more of these problems on that chapter quiz that we're going to have on Wednesday, but we're going to have a few of these on the review sheet as well, so we'll practice that again. All right, let's move on to today's lesson. Okay, so for our first example here, today we are going to be writing equations of a line, and we learned on our last lesson that the equation of a line is your y mx plus b, where you need the slope and you need the y-intercept. Okay, and so given a few information, can you make one? So this one here, you have the slope and you have a point. So it's like you know what m is, but you don't know what b is, the intercept, because they don't give it to you. So what do? Well, we learned some formulas here last time. We learned the point-slope formula, which is if you have a point and you have a slope, which is what we have, then you can get to this line here, the equation. So what you need is to plug in your point, your y1 and your x, and then your slope. So I'm going to demonstrate that here. So we have a y minus y1, and so this is our x1, we can assume, and this is our, well, that's not a y, this is our y1. So our y1 is going to be, let's see, 8 equals m, which is -6, x, which is, so the y and the x, you don't plug things in. They just are there as part of the equation because they are variables. And the x1, we are going to plug in our x value, which is a -1, so -1. And so then we have, what I see is that there are two negatives here, so I'm going to go ahead and make that a plus sign. And then what I'm going to try to do to get this formula that I've already plugged in my stuff, I need to make it look like this. Notice how the y is by itself? This y is not by itself yet, so I need to get there. But first, let's try to maybe simplify this part down. So I see that there's a -6 here, so I'm going to have to distribute this -6. So I'm going to go ahead and do that here. So this is going to be -6x minus 6. I'm going to drop down the other stuff here. So that's y minus 8. That's brought down. This y is still not by itself. I have to add over the 8. So that would cancel. And so y is equal to -6x. -6 plus 8 is +2. And so I have my answer now. And notice that this here, I'm done because y is by itself. These two are not like terms, so I can't combine anymore. And so now, notice how I know what my slope is. I know what my y-intercept is. I can totally graph this line if I wanted to, but we're not going to do that here. We just wanted to write in an equation. All right, let's try out this one here. I want you guys to notice how this question has 2 points, but it doesn't give you a slope this time, so I can't directly use this formula because I don't have the slope. So how can I transform 2 points where I can get the slope? Well, we learned this formula here, the slope formula, very early on, and that's going to help us out here. So with this one here, let's find that slope. So remember, we're going to take our y values and we're going to subtract them. So maybe 7 minus 4 over our x subtracted by each other. So -2 minus 3, negative 2 minus 3. If I were to subtract the top, I get 3. If I subtract the bottom, I get negative 5. So now I have my slope. And so what I'm going to do now is, oh, hang on. That should have been erased. There we go. So what I'm going to do now is I have the slope, but I need to use one of the points. It's like I have one of the slopes now, my m, but I need to use one of these points to build and use this formula so I can build an equation. So the thing is, it doesn't matter which point you use, you will still get the same answer or the same results. So in this case, I'm going to choose the first one here just because it doesn't have a negative sign, but it really didn't matter. So if I use this point here, that's going to be my x1 and my y1. And so if I were to plug it into my equation here, which I'll do here to the side, y minus my y, which is 4, equals 3 over negative 5. I'd just like to mention here, this 5 is the one that's negative, but this here's a fraction, and it doesn't matter whether you have the negative sign on the 5 or the 3. The negative sign just tells you that the overall fraction is a negative. So it doesn't matter whether you put it in the numerator or denominator. As long as you have one negative there, you're good. Thought I mentioned that if no one's ever told you that. And so x minus our x1, which is a 3, right, because that's a 3. So I put it there. And now we're going to work it out. So I just want to mention here, our slope here is a fraction. And we're going to be distributing a fraction. So I just want you guys to be aware that we do deal with fractions in this class. They're not all nice, pretty numbers, but we can do it. We can handle this problem. And I will show you how we can do it step by step. So we're going to bring down or distribute our fraction first. So that's going to be a negative 3 over 5 times x. So that's just this multiplied by x. So I just brought that down. This is a negative and this is a negative. When I multiply to the second term, I get a positive. But now I'm multiplying 3 over 5 with 3. So I want us to think about this first. If I'm multiplying a fraction by a whole number, I can't really do that until I take this whole number and make it into a fraction. And how we do that is always write a whole number over 1. So now it's like, okay, what's 3 over 5 times 3 over 1? Well, you multiply the numerator with the numerator. So 3 times 3, that's 9. So 9 here. In the denominator, 5 times 1 is going to be, oh, sorry, I think I jumped a slide. So what I was saying here was that this 5 times 1 is going to give you 5. And so now I have my fraction multiplied. I'm going to bring down the other side, y minus 4. Let me shrink this down so I have more space. There we go. And so now, remember, we're trying to get this y by itself. It's not quite there yet. So I need to add this 4 to the other side. So that's what I'm going to do. I'm going to add 4 to both sides. So that's going to cancel. So y is equal to, let me use that in green so it can be consistent. Y is equal to negative 3 over 5 plus, oh, but hang on. These two are numbers, so I can combine them. But this one's a fraction and this one's a number, right? So if I want to combine them, I have to add a whole number with a fraction. And I can't do that yet. I have to change this 4 into a fraction. And we just learned how we can do that. We can just put it over 1. And there we go. It's a fraction. But your elementary teacher once said that if you want to add two fractions, you got to make sure there is a common denominator. This is a 5, this is a 1. We can choose the common denominator to be a 5 because I can multiply that 1 by 5, and so then the denominator is 5, right? Okay, but here's the thing your teacher also said. When you change a denominator by multiplying it, you have to also, let me write it this way. When you multiply the denominator by 5, you also have to multiply the top by 5, right? So in this case here, if you multiply, or let me just write this in parentheses instead of a multiplication sign. There we go, that looks nicer. So what I'm saying is, I'm going to drag this fraction down to 9 over 5 because it's already has a denominator of 5. So I don't have to multiply anything to this fraction. But this fraction, I'm going to change that denominator to 5 so I can add it with this fraction. So I multiply the top by 5, so 4 times 5 gives me 20 times the bottom by 5 is 5. Awesome. So now both of these denominators are 5, so that means I can add the numerator. So that's going to be 9 plus 20, which is 29. But here's the thing, do not add the bottom. So this is no 5 plus 5, okay? No 10 in the bottom. You leave the bottom as whatever the common denominator is, which is 5. I'm going to bring down everything else. And, oh, sorry, I think I forgot my x. Yep, I did. And then so we have y equals negative 3 over 5x plus 29 over 5. And I'm done because y is by itself. These two are not like terms, so you can't combine anymore. I'd like to also mention, you could have definitely, when you got to this step, 9 over 5, changed that to a decimal and then added 4 to that. A decimal added to a whole number, which is totally fine, and got this as a decimal number. That is perfectly fine. But here's the thing. If you decide to go on to higher level math like pre-cal and calculus, you need to know how to deal with fractions. Because later on, these fractions aren't just numbers. They also have variables. And in that case, you can't change variables to decimals. You can't use the calculator to help you do that. And so that's why we have to learn the basic knowledge of how we deal with fractions for adding, subtracting, multiplying, and dividing. I will teach that throughout Algebra 2 because I know everyone comes from different backgrounds and needs to these refreshers and be retaught on how you can deal with fractions. So I will do that here. But if you feel more comfortable with changing things to decimal, please do so. We have calculators for a reason. But if you are one that knows you will go on to those, you want to do calculus, you want to do pre-cal, then you need to learn these skills. All right, so let's move on to our next slide and practice writing an equation. 5. Okay, so with this one here, we want to write the line that is parallel and perpendicular to another line. So we want a line that's parallel in problem 1, and it says parallel to this line that passes through this point. So we have to write the equation, which again is this formula here, or this equation. And we probably will need to use that formula that we had before, the y minus y1, mx minus x1, okay? So to use this formula here, I need a point. And so they do give us a point, so that's awesome. So we have our x1 and y1 ready to go. Here's the thing, I don't see my slope, but they did tell me it's parallel. So if I want a slope that's parallel to this line here, I have to make sure it's the same slope. So notice how this equation here has the slope showing. And so I need to steal this slope here. So my slope that I want to use to make sure that it's parallel to this line here is going to be 3 over 4. And instead of using anything else from this line here, I have to create a new line using this slope and this point. And so I have all the ingredients to use this formula here. So I'm going to go ahead and set that up. So this is going to look like y minus y1, which is 4, equals 3 over 4, x minus 1. And so now I'm going to try to simplify this. So if I go ahead and do that here, sorry, I'm going to erase that so that's out of the way. If I distribute this fraction, or 3 over 4, I'm going to get 3 over 4x minus, well, 1 times 3 over 4 is just 3 over 4. And so now I'm going to drop down y minus 4, and I have to get that y by itself, so I'm going to add the 4 over. So adding the 4 over to this side, that cancels. So y is equal to 3 over 4x. Here's the thing. This part here is where you could change 3 over 4 into a decimal by just using your calculator, figure out what 3 divided by 4 is, and that will give you your decimal. And then adding that to 4. And you should have a decimal number here. Or let's practice our fraction skills. So how you can deal with it as a fraction and do it by hand is you got to change this 4 to a fraction. Well, we learned we can put that over 1. Once we put it over 1, you have to find a common denominator. 4 and 1 can both be 4 if you multiply this one by 4. But anything you multiply to the bottom, you got to multiply to the top. And so now we have, I'm going to drag down that 3 over 4. And so if I multiply 4 times 4, that's 16. 1 times 4, this bottom part here, is going to give me 4. And so now the denominators are the same, so I can add the top. But I want you to be aware that this here is a negative 3. This here's a positive 16. If you combine those, you are going to get, let me swing this up here so I have more room. So this is going to be 3 over 4x. If I combine the top part here, negative 3 plus 16, that's going to give me positive 13 over 4. And these now are not like terms, so I can't combine anymore. And that's it. Y is by itself now. So this is my answer. Notice that how easily I can graph it because I know my slope and I know my y-intercept. All right, let's try out this one here. So if something is perpendicular, right, that's when it's opposite signs. So whatever the slope is, it needs to be a negative, and also it needs to be reciprocal. So reciprocal just means that the fraction is flipped. So in this case, my slope here is 4, positive 4, or we can think of it as 4 over 1, right? So that means the slope that I want needs to be negative 1 over 4 because it needs to be opposite in sign, and then I need to flip that fraction. So now I have my slope. I'm going to grab my point here, which is right here. This is my x1 and y1. And I'm going to use my formula. So y minus y1, which is negative 1. My slope, which is negative 1/4, x minus 7. And so I immediately see that there are two negatives here. So I'm going to make a positive, and I'm going to distribute my negative 1/4. And so this would be y plus 1 equals negative 1/4 x. That's two negatives right there. A negative 1/4, negative 7, so that makes a positive. And also I like to mention this 7 here is a whole number, so we can put that over 1 when we multiply the fraction with the whole number. So 1 times 7 gives me 7. 4 times 1 gives me 1. Oh, sorry, 4 times 1 gives me 4. I think I was doing that too fast. And so I have 7 over 4. Now I want to subtract by 1 to get rid of this side, but I have to subtract 1 on this side as well. But then I notice that these two here, we have a fraction and we have a whole number. So I need to change this whole number into a fraction by putting it over 1. And then finding a common denominator. This is a 4, this is a 1. So I probably want my common denominator to be a 4 because I can multiply the bottom here by 4 and the top here by 4. And so working this out, this is going to be, let's make this smaller. Can I do that? There we go. So that's going to be y equals negative 1/4 x plus 7 over 4. I'm just dragging this part down. This part, negative 1 times 4, is going to be negative 4 over 1 times 4 on the bottom, which is 4. All right, these two here are numbers and they're fractions, so I'm going to combine now the numerators because they have a common denominator. They're both 4. 7 minus 4 gives me 3 over 4. Remember, we don't subtract or add the bottom. And so I'm going to bring down everything else. And there we have it. Y is by itself. I can see what my slope is, and I can see what my y-intercept is. And so now we're done. So that was 3 examples of how you can work with fractions, adding, subtracting, multiplying. So hopefully that gives you a better understanding of how we use fractions. So practice that skill with these problems. You're going to see in the homework problems too. Okay, so now we're on our last slide for today. So this is wanting us to write it in standard form for a linear equation. So typically we see the linear equation as y mx plus b, right? But this here is also a linear equation. It's actually the same thing as this. The only thing is when something's written as a standard form, you have to make sure that the x's and y's are on the same side. And typically we will write it on like the left-hand side. And then your number or your constant is going to be on the right-hand side. But also the number, the coefficients here, or the constants, are going to represent integers. So integers are whole numbers that are positives, like 0, 1, 2, 3, or negatives, like -1, -2, -3. The only thing that integers aren't are they're not fractions. So if you see a fraction in a linear equation or like in standard form, then you need to change it to a whole number or an integer before you can say that it's in standard form. So we're going to do that by doing an example here. So here's a linear equation. Notice it's in that slope-intercept form, but we need to change it to a standard form. So first things first, I would say move all your variables to one side. And so what I'm going to do is move this 1 over x, because it has an x, to that side there, to the left side. And so if I want to move that, I have to subtract it off. And so I have to subtract it to the other side as well. So this cancels. Now I have -1/2 x plus y equals -2. I just happen to write my x on this side here. I could have definitely written as y minus 1/2 x. It really wouldn't have mattered. The thing you want to always make sure is that the sign is corresponding. So this was a negative, that y was a positive. Okay, from here, I'm not quite done because this 1/2 here is a fraction. It's not an integer. So I have to change it to an integer. And one way we learn to do that is to multiply by the reciprocal fraction. So how we're going to do that is the reciprocal of this fraction is just it flipped. So this is 1/2, so I have to multiply this by 2 over 1. But here's the thing. I can't just multiply to the x here. I have to multiply to all the other components because the reason why is because you want to anytime you multiply to one thing, you have to make sure you do it to all of it or else you change the equation. So what we're doing is we are multiplying the entire thing by 2 so that way we don't change anything about the equation. We just might make the numbers bigger, but they all get bigger at the same magnitude, if that makes sense. So let me make some room here. Let me scoot this up. So if we think about this fraction, when I made it the reciprocal, isn't 2 over 1 just 2, right? So keep that in mind. So I'm going to distribute this to everything. So 2 over 1 times -1/2. Remember, you multiply straight across or numerator with numerator, denominator with denominator. So 2 times -1 gives me -2 over -1 times 2 gives you 2. And so that's going to be x plus, now remember, this is just a 2, right? 2 over 1 is just 2, so 2 times y gives you 2y. Oh, sorry, that's my highlighter here. 2 times, there we go. And then 2 times -2 is -4. But wait a minute, isn't 2 over 2 1 or -1 in this case? Yeah. So this is really just -1x plus 2y equals -4. And now notice how all the x and y's are on one side and they are all now, the coefficients are integers. And so we are done. It is in standard form. All right, that's it for this journal here. As for homework, I would definitely start trying out Packet 1, pages 4 to 5. Try out those problems there after you finish this journal. Okay, so until next time.